Hey everybody, Doc here again. So we're going to take a look at Chapter 3, starting with measures of center. These PowerPoints are a little longer, so I'll probably do a video for each section. Let's get started. So we're going to take a look at computing the mean of the data set, the median of the data set, comparing the properties of the mean and median, finding the mode of a data set, and approximating the mean with grouped data, and computing a weighted mean. First, let's look at computing the mean of the data set. The mean of the data set is a measure of center. We imagine the data set to be a weight. Then the mean is the point at which the data set balances. And we're going to take a look at these numbers here several times in this slideshow. These are grades of 5 exams. And we can see that the mean here, consider this like a fulcrum point. If these were all weights and their values were weights, it would balance right here at the mean of 81.2. Now remember, a population consists of the entire collection of individuals for which information is sought, and a sample consists of a smaller group drawn from the population. So the method for calculating the mean is actually the same for both. It's just the notation is a little different. The population mean is represented by this little mu, and the sample mean is represented by x bar. So when we're looking at a list of numbers, we call it x sub 1, x sub 2, etc. This just means first number, second number, continuing on. The summation of x sub I, which just means all of them, for 1 to how many ever you have, represents the sum of all of these numbers. So this just means add them all together. The sample mean then is going to be that sum divided by how many you chose from the sample. The population mean is going to be the sum of all of them divided by how many you have in the entire population. So if we take a look at this student taking 5 exams, the population of exam scores are 78, 83, 92, 68, and 85. Find the mean. We add them all together, divide by how many total we have. Now notice that there's only 5 in the population. That's okay. You know, populations can be small groups as well. So, but if you're adding all the data sets, you're going to use mu. And then we're going to divide by the total, which is 5, and we get 81.2. Now notice that it's rounded 1 decimal place past, and the data that you were given are whole numbers. And kind of a general rule, or consider good practice as they say, is to take your data one more place past the decimal than your data set when you're looking at the mean. So since they're all whole numbers, we're going to go to the tens place. Let's look at the median of the data set. Median is another measure of center. It splits the data in half. So here we have an odd number of data. We have a middle number. So that middle number is the median. But if we have an even number of data, then we have to take the 2 that are in the middle and average them, add them together, and divide by 2. So let's compute the median of these exam scores that we looked at before. The one important thing about finding the median is you have to make sure that you have everything in order from smallest to largest. So here we have them in increasing order. And then we take the middle number, which in this case is 83, and that is the median. Now let's say we have a data set of 8 patients that are undergoing a new surgical procedure, and we want to find the median of the number of days in recovery. So we're going to take a look at this data set. First thing we have to do, put them in order, in increasing order. Once we arrange them, then we're going to take a look at the 2 that are in the middle because we have 8 data. So here we have the 2, going to add them together, divide by 2, and we find the median of this data set is 17. Now, if we were doing this on our calculator, we would look at the one variable statistics, and how we would do that is we would go to stat, then highlight the calc menu, so stat calc, and then you will see one variable stats, and then you will choose enter. When you do that, you'll be able to find the mean, the sample standard deviation, the population standard deviation, and then these we'll look at when we go over box plots, the minimum, first quartile, median, the third quartile, and the max. So if you go and to your list like we did before and you put in your 5 exams, then you're going to press stat and go to the calc menu and then hit the one variable statistics command with L1 as the list option, and then you will find that the mean again here is 81.2. Now notice down here it gives you the median also of 83. So you have 81.2 as the mean and 83 as the median. Now let's compare the properties of the mean and the median. Resistant. If you're resistant to something, then you're really not affected by it much. We use resistant when we talk about statistics. If it's not affected by extreme values, very large or very small values in the data set. The median is resistant, which means it's not really affected by it, but the mean is not resistant and is affected by very large or very small numbers in the data set. So we have 5 families with annual incomes. Here's our annual incomes. One family whose income is $25,000 wins a $1 million lottery. So their income increases to $1,025,000. Before the lottery, the mean and median were as follows. The mean before the lottery was $38,000. The median was $34,000. But after the lottery, the mean went to $238,000 and the median went to $44,000. Now notice the median did change, but it was not nearly affected like the mean was with the extreme value of $1,025,000. So the increase would influence the mean and does not influence the median. So that's why we say the median is resistant. Now the mean and the median measure the center of the data in different ways. So when a data set is symmetric, the mean and the median are both equal right in the center. Okay, so when we get a symmetric data set, the mean and the median are together. However, when the data set is skewed to the right, remember that's when you can put your right hand on this side, skewed to the right. There are large values in the right tail because the median is resistant while the mean is not. So the mean is generally more affected by these large values. Therefore, for the data set that is skewed to the right, the mean is often, notice it says often, greater than the median. So in general, the median is going to be here and the mean is pulled by the skew. So whichever way it is skewed, the mean is pulled that way. And then similarly, when we have skewed to the left, that means when you can put your left hand over here, skewed to the left, again, the skew will pull the mean in this direction, and you will see the mean is often less than the median. All right, now we're going to take a look at finding the mode of the data set. Another value that's sometimes classified as a measure of center is the mode. It's not always a good measure of center, but sometimes it is classified that way. So the mode of the data set is the value that appears the most frequently. 2 or more values are tied for the most frequent, then they're all considered to be the modes. So you have to have at least 2. So if you only have one of each thing, there is no mode. But if you have two, say you have two 3s, and then later on you have two 10s, and then later on you have two 13s, and you have a whole bunch of other numbers, the 3 and the 10 and the 13 would all be considered to be modes. If the values have the same frequency, we say that the data set has no mode. So if all the values have the exact same frequency, then no mode. So two ways of not having a mode. If there's only one, and if all the values have the same frequency. So let's say all the values are there 5 times, or all the values are there 3 times, then we would not have a mode. All right, students were asked how many siblings they had. The results arranged in order were here. Find the mode of the data set. Well, we see that we have 4 1s, we have 2 2s, we have 2 3s, and 1 0 and 1 6. So the mode of the data set would be the one that appears most frequently, so it will be 1. Now the mode is sometimes classified as the measure of center. However, that isn't really accurate, as I mentioned before. The mode can be the largest value in the data set, or the smallest value, or anywhere in between. So notice here, this is going to be where our mode is. Mean and medians can be computed only for quantitative data. However, the mode can be computed for qualitative data as well. So if I have a list here of cars rented by an automobile company on a particular day, which car would the mode be? So which one of those would be the mode? Let's see. I see a couple Hondas. I see 1, 2, 3, 4, 5 Toyotas. I see 1, 2, 3, 4 Chevys. 1, 2, 3, 4 Fords. And so it looks like, just at a glance, it looks like Toyota is going to be my mode. It occurs most frequently, so the mode is Toyota. All right, let's approximate the mean when using a grouped data set. Sometimes we don't have access to all the raw data, but we're given a frequency distribution like we looked at in the last chapter. In these cases, we can approximate the mean by using the following steps. We're going to compute the midpoint of each class. The midpoint of each class is taken by taking the average of the lower class limit and the lower class limit of the next larger class. So remember, in histograms, when we divide the classes, we're going to take the lower and then the next lower, and then find the average of those. For each class, we're going to multiply the class midpoint by the frequency. So you add the products and you multiply it by the frequency over all the classes. Then finally, you're going to divide the sum attained in step 3 by the sum of all the data, which would be the sum of all the frequencies. So let's look at an example. Here we have a table that presents the number of text messages sent via a cell phone by a sample of 50 high school students. The approximate mean of the messages sent. So here we have our classes, 0 to 49, 50 to 99. So if I want to find the midpoint, I'm going to add the lowers and divide by 2. So I'll have 25, add these two, divide by 2. I'm going to have 75, etc. So here we have our class midpoints, okay? Our class midpoints, and then we have our frequency over here. We will multiply those together. When we multiply those together, we will get these numbers. After we get these numbers, then we're going to add them together. And I'm going to take the amount of frequency that I have and divide it by the frequency. So again, I'm going to take the sum of the midpoint times the frequency, add those all together, and then I take that sum and divide it by my total frequency, which would be all of these together, would be 50, and get 137. All right, what about a weighted mean? This is how you would, often it's used for GPA. A weighted mean is where some numbers count more than others do. To compute a weighted mean, we'd assign a positive number called a weight to each number, with the numbers that count more getting the larger weights. So here you have your data set like we had before. We're going to call W sub 1 through N the weights. And we're going to take the weight times that value, add them all together, and then I am actually dividing that by the sum of the weights. Let's take a look. So here he has 4 courses. He got an A in stats, which is 5 credits. He got a B in psych, which is 4 credits. A C in English, which is 3 credits. And A in music, which is 2 credits. Now an A is worth 4, B is worth 3, C is worth 2. So compute his GPA. So you're going to take how many credits he had, 5 times that A value would be 4. He got a B in psych, it's 4 credits, multiply it by the value of a B, which is 3. He got a C in English, which is 3 credits. He got the value of a C is 2. And an A in music, which is 2 credits, so you take 2 times that value, which is 4. Going to multiply first, add them together following the order of operations, and then you're dividing by the weights. So 5, 4, 3, and 2, add it across the bottom, and you will find your GPA, or Joe's GPA, to be 3.29. So here's what you should know from what we went over today: how to compute and interpret the mean of a data set, the notation for population mean and sample mean, how to find the median, how to use your TI-84 Plus to compute the mean and the median, the definition of resistant and which measure of center is resistant, how the mean and median are related to the shape of data, including the skewed to the left, skewed to the right, approximately symmetric, how to identify the mode of a data set, and how to approximate the mean for group data and to compute a weighted mean. Okay, so that's all for 3.1, and I will see you soon for 3.2.